Good morning, students. Yes, students, good morning. Anyone please respond? I'm audible and my screen is also shareable, right?
Yes, ma'am.
Okay. Okay. What are the things we have discussed in last session? Anyone? What is MBTBOC and how we are using, right? And that we have seen what? Finite automata, right? In that finite automata, we have studied about DFA and NFA, right? What is DFA? Anyone? What is meant by DFA and what is meant by NFA? Is students?
Only single transition occurs from one state to another on single input symbol.
Okay, this is DFA, right? Okay, ma'am. Then NFA?
In NFA, there exist many paths for specific units input from the current state to the next state.
Okay, ma'am. Okay, thank you. So this is finite automata and DFA and NFA. Okay. Now we are going to see why we are moving from actually in our system and in compiler design, actually we are using the DFA only, deterministic finite automata. Even we are studying NFA and another one subdivision also there, NFA with epsilon. Okay, we will see why we are using this. DFA is very, very important one. We are using the DFA concept only, but we are studying NFA also. Why means so for some problem, DFA is somewhat difficult to construct. Okay, for that reason we are studying NFA also. If the problem is very much, I mean, the problem is big means, then we can subdivide into many blocks, then we can do. Okay, likewise we can do. So for that purpose only we are studying the NFA. Actually in system, in compiler we are using the DFA only, but for the simplified purpose or efficient usage, we are using the NFA and NFA with epsilon also. Okay, so you have know what is DFA and NFA. This is the significance of NFA. Okay, it is useful because constructing an NFA to recognize a given language is sometimes much easier than constructing a DFA. Okay, this is the main point. Why we are studying about NFA, or why we are using NFA means, for some problem constructing DFA is somewhat difficult. So we just construct the NFA. Then after that, after constructing the NFA, we just transfer or convert the NFA into DFA. Okay. It is important because NFA can be used to reduce the complexity of the mathematical work required to establish many important properties in the theory of computation. Okay. In DFA only we are using for easy purpose, and to reduce the complexity, we are using the NFA. After constructing NFA for the problem, we have to transfer, we have to convert the particular NFA into DFA. Okay. This is the main significance of NFA. You have to know why we are studying NFA, why we are studying DFA. Okay. And next, another one subdivision is there in NFA. What is that means? Finite automata with epsilon moves. Epsilon is nothing but empty, without reading any input. Actually, in a DFA, NFA, what we did, we just reading the one input symbol, that may be A or B or 0, 1, 2, anything it may be, right? So once you read the input symbol, you just transfer from one state to another state, right? But here, what is the speciality here is, without reading the input, we just shifting the states. Okay, that is the epsilon moves. Here, please see this diagram. Here, without reading the input, just the particular transition is transferred from state A to state B. Okay, this is the finite automata with epsilon moves. Here it will occur in NFA only, NFA with epsilon. We can say NFA with epsilon. Okay, so we can construct DFA, we can construct NFA, and we can construct NFA with epsilon. Why we are using epsilon means without reading input. Okay, for example, I no need to read any input, but I can I have to travel from one state to another state, mean then I can use this situation. I mean, without reading the input, just make the particular transition say empty, then I can shift my state. Okay, this is called, this is the concept of NFA with epsilon. Okay, an epsilon transition allows an automation to change its state, that is without consuming an input symbol. Okay, without consuming the input symbol, we can shift our states from one state to another state. Okay, and yes, any automata having epsilon moves, then I can then we can say NFA with epsilon. Okay, this is the example for finite automata with epsilon moves, this diagram. And in this under this topic, we may have some problems in 2 marks. Please note how we can do. We have to calculate the epsilon closure. Okay, that means that is nothing but it is for given state X is a set of state which can be reached from the states X with only empty moves. With only empty moves, how much we can travel from the particular state. Okay, this is the epsilon closure. It may ask in 2 marks, and part B questions also based on this concept. Okay, how we can calculate the epsilon closure. This is nothing but how much we can move forward with the help of epsilon from the particular state. Okay, see here, this is the diagram given. This is nothing but NFA with epsilon moves. Okay, now I'm going to calculate the epsilon closure for the states A, B, and C. See how we can epsilon closure of A is nothing but I start here. Okay, here I'm going to start, and where I can end means with the help of epsilon how long I can travel. Here I can from A I can travel to B with the help of epsilon. Again from B I can travel to C. Okay, no other nodes further, so no issues. So A, B, C are the epsilon closure for the state A. Okay, is it clear? And epsilon closure of B for the state B, how we can calculate? We have to start here. Okay, initial state, you have to mention that B, and in that state, from this state, with the help of epsilon, how long we can travel. Here from B to I can travel to C. If any other node is there with D, assume that the node D is available with the epsilon move, means I can say for the epsilon closure of B, B, C, D. Okay, here there is no D node, just the final node ended with a C node. So I can say the epsilon closure of B is B and C. Okay, and for the node C, epsilon closure of C is nothing but the starts the particular state itself, no further nodes moving from C to any other nodes, any other states. Okay, so I can say the epsilon closure of C is C only. Okay, this is the concept of epsilon closure. You have to know how we are calculating the epsilon closure for that particular state. Is it clear, everyone, how we are calculating? We'll go with another one example, then it will be clear for you. Here you please Tell me, find epsilon closure for the following. Students, please mute yourself. Non-deterministic finite automata with epsilon. Okay, this is the automata, that is NFA with epsilon. Okay, now we are going to calculate the epsilon closure for all the states. Please tell me epsilon closure of Q0, what it may be. Epsilon closure of Q0. How we can calculate the epsilon closure? Is anyone, what is the answer for epsilon closure of Q0? Students, respond me. Epsilon closure of Q0. Anyone?
Q0, Q1 and Q2.
Yes, very good, ma. Okay, so epsilon closure of Q0 is Q0, Q1 and Q2. Then epsilon closure of Q1 means
Q1, Q2.
Q1, Q2. Okay. Then epsilon closure of Q2, Q2 only.
Q2.
Yes, okay. Thank you. So, this is the way we can calculate the epsilon closure. Okay. Okay, fine. Here, please tell me, this is another one problem with the same concept. The diagram is nothing but NFA with epsilon moves. You have to calculate the epsilon closure for all the states. Here we have 8 states, for state 1 to state 8. So please, anyone tell me what is the epsilon closure of state 1? Yes. Epsilon closure of state 1.
1, 2, 3, 5, 7, 8.
1, 2, 3, 5.
7, 8.
How you reach 7, ma?
There is a transition from 2 to 7.
No, that is 7 to 2, right? The arrow mark is mentioned. If there is no arrow mark, then you can say. Otherwise, based on the arrow only, you can say. Okay. So the epsilon closure of 1 is 1, 2, 3, 5. That's it. Okay. We can't move further. There is no epsilon transition to reach any other states. Yes, another one is also there.
8.
Can you, yes, 8. Okay. Here the connection is established between the state 1 and 8. So you can add 8 also. And for the epsilon closure of 2 means epsilon closure of 2 means
2, 3, 5.
3, 5. 3, 5 only, right? Yes, ma. 3, 5 only, right? For the epsilon closure of 2, 3 and 5. Okay. And epsilon closure of 3 means epsilon closure of 3, state 3. Any other epsilon transition for the no state 3? Students, respond me. Any other transition with epsilon moves from who's that? A student, respond me. What is the epsilon transition of the node 3?
3, 4, 7.
Only 3, ma'am.
Yes, only 3. not 3 4 7. How you can ma? There is no epsilon transition, right? Here the A only the transition, the input is A. There is no epsilon, so you can say only 3. Okay. For the node 4, state 4, epsilon closure of 4.
4, 7, 8.
7, 8.
4, you have to include the particular state also. Okay, so 4, 7, 8.
8.
Okay, good. Then for state 5,
5.
Only 5.
5 only.
5.
Okay, state 6.
6,
6, 7, 8.
Okay, 6, 7, 8. And for 7,
7 and 8.
no.
2 also is.
Yes, yes, yes. 7, 8. For the no, for the state,
2 is also.
for the state 7,
ఆంటీ
7.
కాఫీ కలుపుకొని తాగారు.
Who's
అది
that? Ma?
కాకుండా
Please mute.
కూర మొత్తం బాక్స్ లోకి తీసా. నువ్వు వెళ్ళిన ఒక 2 minutes కి వచ్చారు.
Students, mute yourself. Okay, fine. So for the state 7, the epsilon closure is 7, 8, and so the 7 is having the transition to 2 also. So you have to note that particular 2. Then, please, anyone?
5.
Yes, 5. Then that's all.
3, ma'am.
Yes, 3. Okay, ma, thank you. So this is the epsilon closure of the state 7. Okay. Okay. Now please tell me what is the type of finite automata here. Okay. This one, which finite automata?
DFA.
What pa?
DFA.
DFA. Is it so? This is DFA. Any other answers? Please, all of you try to respond, interact with me. Tell me this automata is which type of automata, whether it is a DFA or NFA or NFA with epsilon. Please, anyone? Some people said that this is DFA. Others, please, you also try to respond. Students,
NFM.
how you are saying NFA, ma?
Its output is in many states.
Output?
Is in many. Output should be. Output is in many states.
Which one? Which one?
NFM.
Okay, ma. NFA, which with the help of which transition you are saying that this is NFA? No idea. This is NFA, okay, not a DFA. This is NFA because the Q0 state Q0 reading the input B, then goes to where itself, one is itself, that is Q0. Again, another one also reading the input B, it moves to the Q1 also. So for a single input, it moving from one state to many state. Okay, so this is called NFA, not a DFA. Okay, is it clear, everyone? The first one, for a particular state, for a specific input, if you are reading the particular input and moving from one state to many state means then it is called NFA. Okay, here also it reading the input B and what having the loop itself, and it's moving from on the Q0 to Q1 also. So two transition is happen with the help of single input. So we can say this is the NFA. Please, this one. This is NFA or DFA?
DFA.
How, ma? How you are saying this is DFA?
For single input, it is moving to single state.
Q0 reading A and moving to here and B. Okay. Q0, Q1 reading A itself and moving to next state A, B. Yes. So this is DFA. Okay. For a single input, for a specific input, it moving from one state to next one, I mean another state only, not for many paths. It doesn't have many paths. So we can say this is a DFA, and there is no null transition also. Okay. Next one. This is DFA or NFA?
NFA.
NFA, ma'am.
How, ma?
From Q0, it is moving to Q0 for 0 and Q1 also.
Okay, good. So this is the NFA, because for a specific input, it moving from one state to many states. Okay, for input 0, it having the loop between Q0, and so it moving to the Q1 state also. So this is the NFA. Now I have listed some of the difference between NFA and DFA. DFA we know stands for deterministic finite automata, and NFA non-deterministic finite automata. For each symbolic representation of an alphabet, that is the input, there is only one state transition in DFA. Here, no need to specify how does the NFA react according to the some symbol. Okay, it may be goes to within that, otherwise it may go to many states. Okay. So DFA cannot use empty string transition. Here there is no empty, I mean epsilon. There is no epsilon in DFA. But here we just using epsilon. Okay. And the DFA is more difficult to construct, but it is efficient only. It is efficient, but it is difficult to construct, where the NFA is somewhat easier compared to the DFA. Okay. And time needed for executing an input string is less. Time needed for executing input string is more. Here the time is more for executing the input string is more. In DFA, that is less. And we can say all DFA or NFA. Okay, this is the important one. All DFA or NFA. All DFA automata, or we can say that is NFA. But we can't say all NFA or DFA. Okay. All NFA, or we can't say that is the DFA, but DFAs are NFA. Okay. It requires more space and it somewhat less compared to the DFA. Here there may be dead states. Okay. May be used for some problems, but here no need to mention about dead states. And here the main difference we know already in the definition itself, that is the transition function, right? Here the transition function is 2 power q here, but q only. So this is we have studied in the definition itself, mentioned in the definition itself. The transition function is like this, based on the particular state only. There is the only one state we will reach, but here we may reach more than one states. Okay. This is the difference between NFA and DFA. May be asked in 2 marks. You can mention 4 points, 4 or 5 points. That's enough. Okay. Next one, now we are moving to the part B questions. Some important problems are there. It's very interesting. Please be listen and cooperate with me. You please also make a note of it and um, working on that, then only it will be easy for you. Okay. Conversion problem. Now I have explained what is meant by NFA and what is meant by DFA and what is meant by NFA with epsilon. Okay. What are the necessity of each and everything? For example, at last we need only DFA. Okay. But for some problems, DFA construction is somewhat difficult. So that we are studying NFA and constructing the NFA for some problem. After constructing NFA, we have to transfer from NFA to DFA. That conversion only we are going to discuss now. Okay, how we are converting the particular NFA into DFA. What is the procedure? We just now you know, right? Which one is the NFA? Which one is the DFA? Now they may give the problem of NFA and asking you to convert the NFA into DFA. We will see how we can convert. This is NFA or DFA? The particular finite automata is NFA or a DFA?
Ma'am, it is in the difference between NF and DFA slide, ma'am.
What, ma?
Ma'am, it is showing the difference between NFA and DFA slide, ma'am. The slide has not changed.
Okay, okay. Now you can able to view.
Yes, ma'am.
Okay, ma. Thank you. So here the problem is given as this is the conversion problems. We are going to see part B questions NFA to DFA, how we can convert NFA to DFA and how we can convert NFA with epsilon to NFA without epsilon and how we can convert NFA with epsilon to DFA directly. Okay, these are the conversion problem we are going to discuss. These are the very important part B questions. Please concentrate on this. So far we have discussed some basic concept, that means basic terminologies and what is meant by DFA, finite automata, and how we can calculate the epsilon closure. Now only we are moving to the part B section. Okay. So now please tell me, this automata is NFA or DFA? Students? This problem is NFA or DFA?
NFA, ma'am.
NFA. How you can say, ma?
Q1 goes to Q1 from 0 and Q2 also from 0.
Okay, fine. So this is NFA. Now I'm going to convert this NFA to DFA. For this, we have some procedure. Okay. With the help of this procedure, we can convert the particular NFA into DFA. That means we are just doing what? For a specific input, we can transfer from one state to next state. I mean, only one state only. So, okay. This is the concept we are going to implement. How we can we'll see. Steps for converting NFA to DFA. Why we are converting NFA to DFA, ma? Any idea? Why we are converting NFA to DFA? Yes, anyone? Why we are converting NFA to DFA, or why we are studying this conversion problems? Students, are you in the meet? Please respond me. What is the necessity of converting NFA to DFA? Yes, anyone, please? No idea. Not clear, by anyhow, some answer is received. Okay, not clear. No problem, issue, no issues. At last, we need to have what? DFA only. We are using the DFA only. Okay, for our system or for our compiler design, we are using some more concept of TOC, right? We are just using finally the DFA only. But for the construction of DFA is somewhat difficult, so that we are converting first of all, for the language or for the problem, we are going to design the NFA. After that, we are doing the conversion. Okay, these are the steps we are going to implement for conversion. Okay, initially q is nothing but set of states. We have to find the set of states for DFA. Okay, now we having the states for NFA is Q0, Q1 and Q2. NFA we are having three states, Q0, Q1 and Q2. Now we are going to calculate the states for DFA. That is initially pi, that is nothing, empty. Okay, and the next step is add Q0 of NFA to Q dash. I mean initial state of NFA to DFA. Okay, just we are assuming that initial state of NFA is the initial state for DFA also. Okay, so what we are doing, just add the Q0 of NFA to Q dash. Q0 is nothing but mentioning the initial state. Okay, and then find the transition from this start state. Now we're having only one state for DFA, that is initial state of NFA. For that, we need to calculate the transition function. How we can calculate the transition function? Q0, 0, Q0, 1. Okay, what are the inputs we are having here? Zeros and ones. So we need to calculate the transition function for the each and every state. Q0, 0, Q0, 1. Like that, we have to calculate. This is the second step. Once we go with the example, then it will be clear for you. Okay, just you please follow. And step 3, in this third step, in Q dash is nothing but is the states of DFA. Okay, find the possible set of states for each input symbol. If this set of states is not in Q dash, then I mean if any new states is arrived with the transition, here we have done in step 2 we are doing the transition. If you reach any new states, then you have to add the particular state into Q dash. Otherwise we have to calculate the states for each and every input symbol. Okay, the fourth step, in DFA the final state will be all the state which contain F. That means in DFA, how we have to, in this fourth step, that is step 4, it explained that which one going to be the final state of DFA. For NFA, which one is the final state? This Q2, right? Wherever we find the Q2, then that state is assigned as a final state for DFA. Okay, for NFA, Q2 is the final state, and the same procedure. Wherever we find the Q2, that is to be the final state of DFA. Okay, this is the step 4. And step 5, there is no new state occurred, then we can stop the process. Okay, and draw the transition table and transition diagram. Okay, these are the steps. With the help of this, we can convert the NFA to DFA. First of all, if they given one problem, you please start with the solution. In that, you have to draw first transition table for the particular diagram. Okay, here the diagram is given. For this diagram, you have to start with the transition table for NFA. This is the diagram for NFA. So you have to mention transition table for NFA. Okay, with the help of this diagram, you can draw the transition table, right? Is it so? With the help of this diagram, you can draw the transition table for NFA, not for DFA. We are just converting this diagram into table, transition table. Okay, then What is the first step? Now we are going to implement the steps. First step is nothing but initially q dash equal to empty. Q dash is nothing but states of DFA. Okay, and q dash, now the q dash is empty. The initial state of given NFA is, this is given already. For this diagram, the initial state is Q0. We have to mention the states of NFA with the help of curly braces. Okay, but for the states of DFA, we have to mention with a square bracket. Okay, this is the difference. For this diagram is given. For this only we are going to convert into DFA. Okay, so in this given diagram, the initial state is nothing but Q0. We just mentioned that initial state of given NFA is Q0, and we have to do what? Convert the NFA into DFA. We just equalize the both NFA and DFA, right? So let initial state of DFA be. Now we have to assume this is the step 2. Add Q0 of NFA to Q dash. Okay, which one is the initial state of NFA? That is to be assigned as the initial state of DFA also. So initial state of DFA be Q0. Okay, is it clear? Just I'm taking the initial state of NFA and assume that particular state as the initial state of DFA. Okay, this is the second step, and I mark this state as the A. Okay, you can mention anything. It may be there's some letter only for marking the states of DFA. Okay, just I now one state is assigned for DFA, that is Q0. DFA means you have to mention with a square bracket. I have to give name for that, that is A. So for my DFA having only one state, that is Q0, that is named as A. I can give A or Q0, no issues. Okay, you have to give names. In that diagram, you can mention with A, or in that square bracket, you can give Q0 also. Both are same only, but I'm just giving the name for new states of DFA. Okay, it will so far it's clear, right? Just taking the initial state of NFA and assume that particular state is the initial state for DFA and give the name for that. Okay, what's the next step? What's the next step? Now my state, my DFA having only one state, that is Q0. What is the next step? Find the possible set of states for each input symbol. How many input symbols we have here?
3, ma'am. No,
3?
2.
2. Yes, 0 and 1. Only two input symbols are there, that is 0 and 1. Okay, so I'm going to, for this state Q0, I'm going to read the input 0 and input 1 and finding the transition function. Okay, we'll see how we can. Now we'll obtain transition del dash transition for state A. Okay, A is nothing but what? A is nothing but what? Q0. Okay, so A comma 0. I have to calculate the transition for all the input symbol. Here we have only two symbols, zeros and 1. So I have to mention like this, del dash of A comma 0. Okay, this A is nothing but Q0. Okay, Q0, del dash of Q0 comma 0. We have to find this answer from the given diagram or table. Okay, Q0 comma 0, where it's going? Q0 comma 0. It is going inside self loop only, right? So I have to mention with the Q0. Okay, Q0 is Q0 reading the input symbol and moving to the same Q0 itself. So no problem. I just mentioned that Q0. After that, once the state is assigned for DFA, we have to mention with a square bracket. So square bracket of Q0. This is also this is also what? The previous state only. Q0, already we have the state A. if you the new state is arrived, then you have to mention with a different name, but the same only here arrived, so no issues. I have to mention with the A, not transition table, A. Okay, this is A. Okay, then I'm going with the next input symbol, that is A comma 1, del dash of Q0 comma 1. What is the Q0 comma 1? Q0, reading the input symbol 1 and moving to what? Q1. Okay, is it clear, everyone? Q0, reading the input symbol 1 and moving to the state Q1. Okay, then the answer is find out. So I have to mention with a particular state in the DFA. So I have to replace with a square bracket. This is the new state. Already we have only one state, that is A, that is Q0. Now new state is arrived, so we can mention with another name, that is B. Okay, in DFA I'm having now, so far I'm having two states, A and B. A is nothing but Q0 and B is nothing but Q1. Okay, then now I'm having the new state B, right? A is already the state A is already arrived. I have done the transition function for A with the input symbol 0 and 1. Now my new state B is arrived. For that also we have to do the same process, transition function. Okay, B comma 0, B comma 1. Okay, here B comma 0, the del dash transition for the state B is obtained as B comma 0, del dash of B is nothing but what? Q1 comma 0. Q1 comma 0 is going to the same Q1 itself. So sorry, Q1 comma 0 is going to Q1 and so Q2. Q1 comma 0, it moving to itself, and so the Q2 also. So I have to mention both the things. Q1 comma 0 is moving to Q1 and so Q2. I have to convert this into DFA state. So mention that particular into square bracket. This is the new state, right? This is not equal to A, not equal to B. Sorry, this is not equal to A, not equal to B. So I can mention the particular things into the state C. Okay. And the input 0 is processed and the input 1. For the state B, we have to mention with the another one state, another one input symbol, that is 1, B comma 1. B is nothing but Q1. Just replace the B with the Q1. Q1 comma 1 means Q1 where it's moving, Q1 reading the input symbol and moving to the same state, that is Q1. Okay, so I have to mention with the Q1 comma 1 is nothing but Q1. I have to mention with square bracket because it is a DFA. We are just converting NFA to NFA into DFA. So this is Q1. This is already we have, what is that? The state B. So I just mentioned with the B. What is the next step? Anyone please? What is the next step? Yes, students, tell me what is the next step? Shall I point out some of the numbers? If you answer no issues, I will proceed. Otherwise, I have to point out some names. What is the next step?
Transition for state C.
Yes, very good. Thank you, ma. So next we have to go with transition function, transition for state C with the input symbol 0 and 1. Okay. So we'll obtain transition on the state C, C comma 0. What is the C? C is nothing but what? Q1 comma Q2. Okay. Q1 comma Q2. Here I have mentioned the C with the Q1 comma Q2 with the input symbol 0. Two states are there, so we have to do what? Union function. Q1, we have to calculate Q1 comma 0 union Q2 comma 0. Okay. where the q1 comma 0 is moving, we have to check with that diagram, given diagram, q1 comma 0, q1 is here, q1 comma 0, where it's moving itself, and so q2. So itself and means q1 and q2 union q2 comma 0, where the q2 comma 0 is moving, q2 comma 0 itself. So that is q2. No need to repeat. Okay, we can mention only one time. So q1 is updated here, and we have two q2, so we just mention one q2, q1 and q2. This is what nothing but the state C. Already we have, there is no new state. Okay, the next one, C comma 1, transition for the state C with the input symbol 1. Already we have to the same procedure we have to do for the C. We have to replace with the q1 and q2 and read the input symbol 1, q1 and 1, again doing that q1 and 1, and union del of q2 comma 1. What is the q1 comma 1? We have to find from the diagram, and q2 comma 1. Here we have q1 and q2. We have to mention with only one. Q1 is repeated 2 times. No need to mention again. We just keep in only 1 time. So q1 comma q2. This is also nothing but what? The state C only. Okay. There is no new state here. So no need to go further. Just we can stop here. Is it clear, everyone? Any doubt, please ask me. I will explain again. Without understanding, you can't go with this these problems. It's very important problem, NFA to DFA. Now we have the transition function for the DFA. Okay, then tell me what are the states we have for DFA now so far? Students, what are the states we have for DFA from this transition? This one, this is the first state A. Okay, then B and C. Okay, 3 states we have for DFA. With the help of this, we have to draw the transition diagram for the DFA. Okay, what is the state A? We can mention A, otherwise the Q0. Okay, state A and state B and C. 3 states we have in DFA. Okay, in that we have to mark all the function, transition function. A comma 0, it's moving where? A comma 0. A comma 0 moving where? Q0, that is again A. So it having the loop inside A comma 0. We have to draw the transition diagram like this. Okay, and A comma 1. A comma 1 where moving? That is B. That is the state Q1. Here mentioned like a B only. So we can draw the connection between A and B with the input symbol 1. And B comma 0. B comma 0 is moving to the state C, and B comma 1 is moving to the itself. 0 is moving to the state C. Okay, and B comma 1 is transition to the same state itself. And C comma 0. C comma 0, it's having own loop. And C comma 1 also the same thing. Okay, this is the final transition diagram of DFA. Is it clear? For that, you have to write transition table also. How we can write the transition table, ma? How we can write the transition table? In that row, what we have to mention? Is row we have to mention what? Students, are you in the meet? Students, are you in the meet? Respond me.
States, ma'am.
States, yes, that is A, B and C. Okay, you have to mention like this. In the column, you have to mention the input symbol 0 and 1. You have to make the fill this table also. A comma 0 means A. No need to use the block, I mean name A, B. You have to mention with the particular states. C means Q1 comma Q2. You have to mention with here in this state you have to mention with Q1 comma Q2 like this. Okay, this is the resultant DFA. Okay, A, B and C. You can mention the particular state also. In square bracket, you can mention Q0. Like that also you can give. Okay, both are same only. You have just assigned the name to the particular state A, but the state is actually Q0. Like that you can mention. And how we are finding the initial state and final state here? Initial state, already we have assumed that initial state of NFA is the initial state of DFA. NFA of initial state is nothing but Q0. So that is in the A. So I can mention this is the initial state. How you can find the final state. Okay. For that we have one procedure, that is if the Q here this NFA Q2 is the final state, right? Wherever we can find a Q2, I can say that is the final state. For example, where we have yes in Q2 in C, the state C, we have the Q2. So this is the final state. For example, if we are having the here also for the for the A state, we are having just Q0, right? For example, assume it may have Q2 also, that is Q0 comma Q2 means the particular A state also the final state. Okay, wherever you finding the final state of NFA, that is the final state of DFA also. Now here just we are having the Q2 in the state C. So I can say the C is the final state. Okay, so that I have mentioned with a double circle. Is it clear, ma? So this is the way only we can draw the transition table also. Now our diagram, NFA diagram is converted into DFA like this. Okay, for a specific input, it reading one state to another state. There is no many other path. Okay, in the table also you have to mention initial statements with the arrow mark, final statement with this multiplication operator. This specification is having some marks. Don't forget to mention. Okay, you have to mention the initial state, final state with a transition table, and so the transition diagram you have to mention. Without initial and final, our diagram is not considered. Okay, anyhow, no other I can't give any other not a single marks for you without mentioning the initial state, final state. So you have to do you have to mention the initial and final state. Is it clear, everyone? Any doubt how we are converting NFA to DFA? Any doubt, ma? If students have any doubt, or it is clear for you? Students? Having any doubt in conversion of NFA to DFA? What is the procedure? Yes. Anyone, please? Can you explain the how we are doing the conversion? Interact with me, then only you can able to follow, and it will be interesting for you. Otherwise, it is boring. Anyone come forward to explain what is the process we have done for converting the NFI to DFA? Give some response, ma. It will be clear for you. Otherwise, need some clarity or having some confusion, having some any doubt, please. respond me, then only I can know what how the class is going. Any doubts? Yes. Shall I point out some people? Any doubt, students? No doubt. Can I take like? Okay, okay, fine. No doubt. So, how we are doing the conversion? First, you take the initial state of NFA and consider that is to be the final initial state of DFA also, and we make some give some name to the particular state. After that, for that particular state, we have to find the transition for all the input. Here we are having only two inputs, 0 and 1. If you're having 0, 1, 2 means you have to go with 3 transition. Otherwise, if you have only one input means you can go with only one transition itself. Okay. So for that state A, you have to make you have to find the transition of A comma 0, A comma 1. If you find a new state, then you have to give another name. Otherwise, the same thing only, the previous state only. Okay, then if new state is arrived, then you have to do the same process. For that new state, you have to calculate the transition function for all the input b comma 0 and b comma 1. Okay, and here also if new state arrived, you have to go with the transition function, otherwise you can stop. Here new state is arrived c, so c comma 0 and c comma 1 you have to calculate. If two states are in the particular states means you have to use the union function. Okay, after finding all those things, you can draw the transition diagram and transition table. Okay, is already I have said that is in the name of A you can give Q0, and in the name of B you can give Q1, in the name of C you can give Q1, Q2 also. Okay, you can denote like this also. Okay, have another one example please. Make this as a homework. Students, make a note of it. Here I am having the NFA diagram is given, Q0, Q1 and Q2. How I can say this is the NFA?
Q0 is going to two states for 0.
Okay, ma. Okay, so this is the NFA. So I'm going to convert the particular NFA into DFA. This NFA is drawn for the language ends with 0. The word or string end with 0. That's why this diagram is drawn. Okay, in that you have to start with the solution. How we are studying for this diagram, you write the transition table first. Okay, then you go with the what conversion. Here, see here, the q1 comma 0, q1 comma 0 is moving to no one, right? So I can mention like pi. Okay, no other transition means I can give pi. Now the NFA diagram is there and NFA transition table also is there. Now you need to make a conversion. Please do and update me, students. Otherwise, you can do like homework also. Please make a note of it. Try yourself, and if you have any doubt, please ask me tomorrow. Okay? Have you noted all of you?
Yes, ma'am.
Okay, ma. With another one example is there. This one. Make a note. Tomorrow you please solve both the problems and come. If you have any doubt, please ask me. No issues. This is also NFA. you have to convert the particular problem into DFA. Okay. Have you noted, all of you? All of you, please try. Don't simply listening or sitting is not give more effective results in the case of TOC. Okay, you have to work out. Then only you can find where we missed or where we have to clarify like that. If you practice, then only you know. Have you noted, all of you?
Yes, ma'am.
Okay. Okay, ma'am. The next problem is nothing but conversion of epsilon NFA to NFA, that is with epsilon to without epsilon. Okay, epsilon is only having transition in NFA only, not in the case of DFA. We doesn't talk about epsilon. Epsilon is involved only in the NFA. So with epsilon to without epsilon, we are converting. Okay, so why we are using epsilon in NFA? Some cases we need to transfer, we have to transfer from one state to another state without reading the input. Okay, some problem may like that, without reading the input, without doing any process, I just shifting my states. Okay, my process is over, I no need to go further, just I shifting the state and reaching the final state and come out. Okay, in that case I can use epsilon. Okay, epsilon is nothing but it is like input symbol. Okay, but no other value for that. Okay, how we can convert, we will see. For that epsilon, we have three conversion problem. One is NFA to DFA, already we have discussed, and another one is epsilon NFA to without epsilon, another one epsilon NFA to DFA directly. Okay, these three problems. In first problem, no need to consider or no need to consider an epsilon closure, but another two, NFA with epsilon and NFA with epsilon to DFA directly, we have to calculate the epsilon closure for all the state. We know, right? We can calculate the epsilon closure for the state. Just I'm try to give overall about how we can do the epsilon NFA2 without epsilon. Okay, so we have to first here in this problem we have to calculate the epsilon closure for all the states first. Here we have only two states, Q0 and Q1, right? So we have to calculate the epsilon closure for Q0 and so the Q1. Okay, we know how we can calculate the epsilon closure, right? Epsilon closure of Q0 is nothing but Q0 comma Q1, and epsilon closure of Q1 is nothing but the Q1. Okay, the first step is nothing but to find the epsilon closure for all the states. Okay, here also the initial state is the same for NFA with epsilon and NFA without epsilon. Okay, for NFA with epsilon, here the initial state is Q0. The same state I can assume that initial state for NFA without epsilon also. Okay, again the same process. Now find the transition of Q0 on input 0 comma 1. Okay, now here in the case of NFA DFA, we are just finding the new states by doing the transition function and finding the new state, and for that new state we are finding the transition function, right? In the case of here NFA with epsilon to NFA without epsilon, we are just transition, we are finding the transition function for the states. Okay, here the states are 0 comma 0, next Q0 comma 1, Q1 comma 0, and Q1, Q1, 0 and Q1, 1. That's all. Okay. This is the process. With the help of this, we can convert the NFA with epsilon to NFA without epsilon. The first step is nothing but we have to find the epsilon closure. We know already how we can calculate the epsilon closure. Is it so?
The slide is an example 3, ma'am.
Oh, sorry, ma. Sorry. Okay, the time is over, I think so. We will see in the next class. Please work out the example 2 and 3. Tomorrow, please complete and come and update me how the status, and if you have any doubt, please ask me. Okay. Thank you, students. You can leave now for the
Students, do not leave this meet. You will be having a 10 minutes break. After that, you could rejoin. Okay.